Welcome to the Vitality Equation, exploring research in health and well-being one paper at a time. I'm excited about our topic today, personalized biohacking strategies for optimizing human performance in space. It sounds like something straight out of a science fiction movie.
It does. It's also incredibly relevant. As we look towards longer space missions, even the prospect of colonizing other planets, we really need to get serious about how the human body and mind will cope with the extreme conditions.
Absolutely. Think about the toll even relatively short stays on the ISS takes on astronauts. Bone density loss, muscle atrophy, radiation exposure. Now amplify that for a multi-year mission to Mars.
And it's not just the physical, is it? The psychological impact of isolation, confinement, altered light, dark cycles. That's huge too.
Exactly. The mind-body connection is paramount. We can't just focus on physical resilience. We have to address cognitive well-being and mental fortitude as well. It's all interconnected, isn't it?
Totally. So where do we even start with personalized biohacking in this context? It feels overwhelming.
I think we start with understanding that each astronaut is going to respond differently to the space environment. Their genetic predispositions, their pre-existing health conditions, even their personality, all of that is going to influence their experience. So a one-size-fits-all approach just won't cut it.
That's a great point. It's like personalized medicine, but for space. We need to gather a lot of data on each individual before, during, and after spaceflight. Everything from their microbiome composition to their cognitive performance under stress.
And then use that data to tailor interventions. Maybe some astronauts need specific exercise protocols to combat bone loss, while others benefit more from targeted sleep interventions to maintain cognitive function. It's got to be adaptable too, constantly adjusting based on how they're responding.
I'm thinking about things like nutrition. We know that certain nutrients can support bone health, reduce inflammation, even boost mood. But what's optimal for one astronaut might not be for another. We need to move beyond just providing basic sustenance and start thinking about food as medicine.
Yes, and then there's the whole field of neurofeedback and cognitive training. Could we use these techniques to help astronauts develop greater resilience to stress, improve their focus, or even accelerate their learning abilities in a new environment?
Definitely. And let's not forget about the power of light. Circadian rhythm disruption is a huge problem in space. Could personalized light therapy protocols, mimicking natural sunlight cycles, improve sleep, mood, and overall health?
It makes me wonder about the potential of meditation and mindfulness practices too. Could we train astronauts to use these techniques to manage stress, regulate their emotions, and maintain a sense of inner peace in a highly challenging environment? I'm thinking about the benefits I experience with my own practice. I read a news article recently, and it makes me think about how things affect me and my neighbors.
Oh yeah? What did you read?
It was about the spotted lanternfly and its presence in New York wine regions. While it's concerning, it also made me think about managing stress and cultivating a sense of grounding, even when facing external challenges. Sort of like, how can we use our inner resources to cope with environmental stressors?
That's interesting. It ties in with the idea of building resilience, not just physically, but mentally. It's about how we reframe those external challenges. A proactive rather than reactive strategy. I even thought about that article in the context of cognitive restructuring techniques. How can we manage anxieties related to threats to our investments or well-being, just like dealing with a potential lanternfly infestation?
It also highlights how environmental factors can disrupt daily routines and affect things like sleep. The lanternfly stress can be so impactful. The resilience to that stress makes me wonder about strategies I can use to handle all the stressors.
I agree. In space, that ability to self-regulate becomes even more crucial. They can't just walk away from a stressful situation.
Exactly. They're confined, isolated, and constantly exposed to stressors. Cognitive behavioral therapy CBT techniques, things like thought challenging and mindfulness, could be powerful tools. We could train astronauts to identify and modify negative thought patterns, and to develop a greater sense of control over their emotional responses. It would be interesting to see if these kind of therapies could be applied to lanternfly threat.
And maybe even virtual reality simulations could play a role, exposing astronauts to realistic scenarios, equipment malfunctions, communication breakdowns in a safe, controlled environment. That way they can practice their coping skills and build confidence before they actually encounter those situations in space, like a flight simulator, but for mental resilience.
That's brilliant. I'm also thinking about the gut microbiome. We know that the microbiome is heavily influenced by diet, stress, and environment, and it, in turn, influences everything from immunity to brain function. Could we use personalized probiotic or prebiotic interventions to optimize the gut microbiome of astronauts, supporting their overall health and well-being?
There's also the potential for epigenetic interventions. We're learning more and more about how environmental factors can influence gene expression. Could we use targeted interventions, like specific dietary changes or exercise protocols, to optimize gene expression in astronauts, protecting them from the negative effects of spaceflight?
That's amazing to think about. It suggests we have more control than we think.
It really does. The article on the spotted lanternfly mentioned how the composition of fatty acids in adipose tissue is influenced by lifestyle. It made me realize that consistent, mindful practices, rather than quick fixes, can have a lasting impact. It is very empowering that I can influence this.
I agree. The subtle underlying mechanisms of protein aggregation could be instrumental in developing cognitive interventions far beyond lifestyle changes or meditation alone.
I like the research that suggests a pathway for how lifestyle choices have direct cellular level effects. It gets me thinking about my own potential to influence my body's internal environment.
I wonder what forms of movement and eating might lead to the most positive changes. And it's exciting that there are actionable lifestyle-based ways to make positive changes.
I'm curious too. I wonder if there's a way to optimize sleep and exercise protocols to influence cellular environments in a protective way, or if different sleep-wake cycles or exercise types could influence interfacial potential.
Absolutely. If cognitive functions are disrupted by the processes of protein aggregation, can we develop techniques to counter it? Could manipulating membrane potential through neuroplasticity-inducing activities help reduce cognitive decline?
Yeah, I wonder if the physiological stress response affects that potential. If it does, maybe certain kinds of exercise could help mitigate that.
It's fascinating how these different fields of research are converging. It is exciting to see what happens. But is all this even feasible in the real world?
That's the million-dollar question, isn't it? Spaceflight is already incredibly expensive. Adding personalized biohacking strategies is going to add another layer of complexity and cost.
And there are ethical considerations too. How far do we go in manipulating the human body to adapt to space? Are we creating a new class of super astronauts that are fundamentally different from the rest of us?
Those are important questions. I think we need to approach this with a strong ethical framework, ensuring that we're prioritizing the well-being of the astronauts and not just pushing the boundaries of human performance at any cost. I think lifestyle choices are crucial. For example, the gut microbiome. We could use personalized probiotic or prebiotic interventions to optimize the gut microbiome of astronauts, supporting their overall health and well-being.
Agreed. And transparency is key. Astronauts need to be fully informed about the potential risks and benefits of any biohacking intervention. They need to have a say in what happens to their bodies and minds. Also, we need to be aware of the potential for unintended consequences. Manipulating complex biological systems can have unforeseen effects.
Maybe a phased approach is the way to go. Start with the least invasive interventions, personalized nutrition, exercise, sleep protocols, and gradually introduce more complex strategies as we learn more and understand the risks better. A phased approach is always better.
That makes sense. And we need to be rigorous in our data collection and analysis. We need to track the effects of these interventions on every astronaut, both in the short term and the long term.
I agree.
Absolutely. We need to build a comprehensive database of astronaut health data, linking it to their spaceflight experiences and their biohacking interventions. Only then can we really understand what works and what doesn't, and refine our strategies over time.
It's a huge undertaking, but the potential payoff is enormous. If we can successfully optimize human performance in space, we're not just enabling longer and more ambitious missions, we're also learning things that can benefit people back on Earth. Right?
That's exactly what I was thinking. Many of the biohacking strategies we're talking about, personalized nutrition, exercise, stress management, are relevant to anyone who wants to improve their health and well-being. I mean, that Lanternfly article had me thinking about changes I can make.
The research on cognitive training and neurofeedback could have implications for treating neurological disorders, improving cognitive function in older adults, or even enhancing learning abilities in children. If we can understand how these underlying cognitive processes work, we can expand into improving people's lives.
And the insights we gain into circadian rhythm disruption and sleep optimization could help us address the growing problem of sleep disorders in our society. I mean, who isn't sleep deprived these days?
It's like space exploration becomes a catalyst for innovation in healthcare and wellness, right? What we learn from pushing the boundaries in space can trickle down and improve the lives of people here on Earth. That's really exciting.
Absolutely. It's a translational perspective, taking what we learn in one context and applying it to another. And that's where the real value lies.
So, if we were to suggest future research directions in this area, what would they be?
From my perspective, I'd love to see more research on the impact of mindfulness and meditation practices on astronaut health. Could we develop personalized meditation protocols that are tailored to the specific stressors of spaceflight? And how would these practices affect their microbiome, their gene expression, and their cognitive function? I think it could be very powerful to look into this.
I'm most interested in exploring the potential of targeted cognitive training interventions to enhance resilience and adaptability in astronauts. Can we develop specific cognitive exercises that strengthen the neural networks involved in stress regulation, decision-making, and problem-solving? And how can we use neurofeedback to help astronauts learn to consciously control these neural networks?
I think we need to dive deeper into the relationship between sleep, exercise, and membrane potential. How do different types of exercise and sleep-wake cycles influence membrane potential? And can we optimize these lifestyle factors to create a protective cellular environment for astronauts? I think it would be cool if researchers looked at how the physiological stress response affects that membrane potential.
These are all fantastic directions. It really feels like we're just scratching the surface of what's possible in terms of personalized biohacking for space exploration. I look forward to seeing the research in the coming years.
Me too. It's a challenging but incredibly exciting field, with the potential to not only help us reach for the stars, but also to improve the lives of people here on Earth.
Definitely. It shows a new way of looking at space research that incorporates mental health and physical activity.
Well, that brings us to the end of another episode of the Vitality Equation. Thank you all for listening, and we'll see you next time.
Thanks for having me.
Bye.